Okay, today's October 26, 2011. This is lesson 5.3. These are common factors. Okay? So, we're doing common factors today. What that means is this is the opposite of distribution. Okay? So I'm looking for a number that is divisible into both of these terms. So we have two terms, and we need to find either a number or a variable that divides into both. Can any of you guys see a number that divides into both? One goes in, sure, but one won't change anything. I want a whole number. Josh? 3. So, what that means is I'm going to divide both of these terms by the number 3. Okay? That doesn't mean that 3 that we divided by disappears. What happens is in our next line, we're going to have brackets, and the 3 that we took out will go on the outside of the brackets. What goes inside the brackets is what these equate to. And what that means is we take 3x and divide by 3. Does anyone know what we'll get? 1x. So that goes inside the brackets. And what would 3 divided by 3 be? Plus 1. Okay? So we're going to rewrite our final answer here. The 3 we divided by, that's considered the greatest common factor, because I'll be looking for the greatest common factor out of these. We took the 3 out. It's on the outside. And we divided both terms by 3, and we ended up with x plus 1. So now we factored. Remember I said this is the opposite of distribution, what we had just gone over. So what that means now, I'm going to take that answer. This is to check. We just learned distributive property. I take my answer and I do the reverse. Factoring is the reverse of expanding and simplifying. I multiply 3 by both terms. What do I end up at? 3x plus 3, which is exactly what we started with. So that is a way we could check our answers.
So do we win?
Okay, we have another example here. Okay, and this one we have x squared times 3x. Now we know there's technically a 1 in front of this. So if I'm looking for a number that divides into this, I could always take 1 out, but that won't change anything if I divide by 1. Okay, so we don't need to divide by 1. Is there another term I could divide both of these by? What variable is in both of these? X. There's an x in both of these. So in this case, we're going to divide both terms by x, which means where does the x go? Outside of the brackets or in front of the brackets. So we have our x. And then we figure out what, when we divide them, what that equals to go inside of this. So what would x squared divided by x be? Just x. Okay, or x to the power of 1. Remember our exponent rules? Technically, this is to the power of 1. So I would subtract 2, subtract 1, and I would get 1 here. Okay? And what is 3x divided by x? Just 3. The x's will cancel each other out, and we'll be stuck, or not stuck, but we'll be left with just 3. So our final answer is x times x plus 3. Okay? And if you ever need to check, we would redistribute. This is the last time I'm going to check, okay? I would redistribute. I have x plus 3. Times that by both, we'd get x squared plus 3x, which is exactly what we started with. That means we could take numbers out, which is what we did in the first one. We took the number 3 out. Or you could take a variable out. You can factor by both. In fact, you can do both at the same time. We're going to work on. All right, our next example, we look at these terms. We have coefficients of 25 and 15. Does anyone know what a greatest common factor would be for those two numbers, or just a common factor? 5. We could take 5 out of both of those. What about k to the power 6 and k to the power 4? I could take k out, but I could take more than just one k. Okay? In fact, because of the way division works, if you guys remember in our other question, we had our two x's. This is technically to the power of 1. You take whatever variable to the lowest exponent, you can take that out. So we took x to the power of 1 out of both of these terms. That was the lowest exponent, okay? And this one, what's the lowest exponent of a variable? 4. So that means I could take k to the power of 4 out of each of these, okay? So we're going to take 5 like we said. And what variable? K to the power of 4. So we're going to divide each of these terms by that number. Remember, that number goes on the outside of the brackets. We get 5k to the power of 4. And now we divide. What would 25 divided by 5 be? 5. Now when we divide our variables, k to the power of 6 divided by k to the power of 4. Yes, it's k to the power of 2. All we do is subtract the top number by the bottom number. So 6 subtract 4 is 2. So we get k to the power of 2. And then in our next one, 15 divided by 5, 3. And what is 4 subtract 4? 0. So there's no variable. Another way you can look at that, it would be k to the power of 0. Whoops. What would k to the power of 0 be? 1. What's 5 to the power of 0? 1. Anything to the power of 0 is 1. So I could put 3 times 1. Does that change anything? Still just be 3. So we can just take the exponent right out. So our final answer for our greatest common factor is 5. K to the power of 4 multiplied by the brackets 5. K to the power of 2 plus 3. Okay, our next example. Okay, in our next example, we have 3 terms. We could still find a greatest common factor of 3, 4. We could have a million terms, okay? And this one, we're using a trinomial. That means there's 3 different terms. I'm going to look at all the coefficients first and find out what the greatest common factor between these 3 numbers would be. Does anyone know? 7. So we know the greatest common factor between all 3 of those would be 7. Next thing we look at is our variable of c. Remember, we take the variable out with the lowest exponent in the question. What's the lowest exponent here? C to the power of 1. Okay? So we're going to take c to the power of 1 out of everything. And finally, our d exponent. What is the lowest d exponent? D to the power of 3. So we've taken, this will be our greatest common factor, which is 7c d to the power of 3. And now inside the brackets, we're going to put what these equate to. 21 divided by 7 is, okay, c4 divided by c to the power of 1 is c3, good. And d3 divided by d3, no, would just be 1. It's just like 5 divided by 5, 10 divided by 10. But we don't need to put that 1 in. So imagine they cancel each other out and it's gone. Okay? Our next part. What is negative 28? The d's gone. Negative 28 divided by positive 7. Negative 4. What is c to the power of 2 divided by c to the power of 1? Just c. There is 1. 2, subtract 1, remember. This is to the power of 1. And d5 divided by d3 is d to the power of 2. Good. 7 divided by 7, so plus 1. C divided by c, not 0. It just cancels itself out, okay? It's not c to the power of 1. It would technically just be the number 1. But we don't need to write the number 1. It's not that important. It won't change anything. And d3 divided by d3, they cancel each other out again. So we're just left with 1 as our last term. So our answer, this is our greatest common factor. And inside the brackets, we had 3 times c to the power 3 minus 4 times c times d squared plus 1. Okay, same idea. We're looking for the greatest common factor, or the common factor in here. Is there a common factor between 5 and 7? What? Just 1. 1's not going to change anything, so we're not going to take 1 out. What about x and w? Can I take a common factor out of those? No, they're two different variables. I can't do anything with that. Same with x and z. Okay? And y, w, y, z, I can't take anything out. So am I able to factor this any lower?
No.
That's done. Okay, ready? This is what you would write.
Y is factored with capital.
Okay, in this question, we're looking for a common factor again. But if you notice, this question is written quite differently. We have brackets attached, okay? And essentially what's happened is whatever two numbers were here, they factored 3 out of them. They've already done a little bit of common factoring, okay? So they've factored 3x out of both those brackets. Do you guys see any similarities now in these? Because this is technically a term and this is a term. Do you see any similarities in these? The brackets are the exact same. So what that means is I can actually factor the bracket out of both of these. So in other words, I'm going to divide by y plus 1 and y plus 1. So what will end up going to the outside? Yep. So we get y plus 1. And then what's left inside the brackets? So y plus 1 divided by y plus 1, they cancel each other out. What's left? 3x. Same idea on the other one. Y plus 1, y plus 1. What's left? Positive 7z. So our final answer is y plus 1 times 3x plus 7z. Okay. We have a very large number here. So there are 4 different terms. If I look at them, there actually is not any common factor here. If I look at them as all 4 together. Okay? But if I look at them as pairs, 2 terms in 2 terms, that's going to change this question. So I'm going to bracket them off just so I realize what I'm working with. I've inserted these brackets. They haven't changed the question, okay? If I take the brackets off, it's still going to be the exact same question as above. But now what I'm going to be doing is I'm going to find the common factor between these two and the common factor between these two. So what would a common factor be of 9 and 15? 3. And what about x squared and x? Just x to the power of 1, okay? What about a common factor for 3x plus 5? Just the number 1, okay? So we can just leave it. It's not going to change anything. So, okay, you can write it in. That's fine. So now on the outside, we have 3x. And inside the brackets, what do we get? 9 divided by 3 is 3. And x2 divided by x1 is just plus 15 divided by 3. X divided by x cancels out. We have plus 3x plus 5 again. Okay. Now I look at these terms. Okay, I've split them into 2. Do you see any other similarities? I can take the brackets out. So I'm going to divide both of these by the brackets. So on the outside, we get 3x plus 5. All right? And what is left on the inside of our bracket? So 3x plus 5 cancel out. We get 3x. And then in the other one, 3x plus 5 cancel out. What number is left when they cancel out? 1. So we get plus 1. Final answer.